And today, I want to tell you a story about racing and how we use perspectives to win the world championship. To begin with, I want to ask a question. How would genetics, computers, and racing have to work together? Well, that happened in our club. This is an AI simulation program that uses genetic algorithm to find the most optimal racing line on a given road course. Genetic algorithm uses the idea of natural selection. This is fascinating, as three seemingly unrelated concepts, genetics, computer science, and racing, can work together so well to create such a powerful tool. But now look at this picture again. I've labeled line 1 and line 2. Line 1 is significantly faster than line 2. But this is only simulated. How will we actually achieve it in real life? What is the most important component of a race car that we have to consider in order to achieve this racing line? Well, the tires. The tires, it provides enough traction for the car to drive its desired path. So how do we actually increase the traction of a tire? We thought, why don't we analyze it from a physics perspective? And we found the tire material, the radius of the tire, and the contact surface area of the tire. But because of the strict competition rules, we were only able to change the tire material. Then we thought, how do we actually increase the tire material? How do we actually manipulate it? Then we came by, after looking around, looking at what can actually increase the tire material, and we found two potential candidates: honey and glue. Why don't we just brush that onto our car? Why don't we just make the tires more sticky? Why don't we just increase the traction or increase the acceleration using honey and glue? And this innovation shows how world innovations can be inspired by the world around us. Even something so small and irrelevant can give you a new idea to the solution. But we were faced with another issue. The additives were too sticky at times. They not only stuck on the tires, they also got stuck on the ground. And after trials and after times, instead of increasing the traction, the additives came off. It wasn't enduring. So we had to go back to the drawing board. We needed to find another way to increase this endurance. We tried different methods, different physics methods, but none of them seemed to work. Then it was until a chemistry class, our design leader gave us an idea. Why don't we use chemical mixtures to dissolve these additives into the tire rubber? Wouldn't that just increase the traction while also maintaining the endurance? We thought that would be perfect. And then we applied it using different chemical proportions and found multiple different ways to increase the endurance. This shows this interdisciplinary approach of chemistry and physics demonstrates how sometimes by understanding the problem through a different field or discipline can help you, give you hints to the actual solution. But engineering is not just about applying this interdisciplinary knowledge to solving problems, but also about creating efficiency and optimization. This is a car model that we were assigned in the competition. It consists of a drivetrain that uses a heavy metal rod. But during the competition, we realized that this car was way too heavy. It was inefficient. We wanted faster speed. How will we do it though? Then this comes our biggest problem that we've ever met yet: weight reduction. How do we decrease the weight to increase its acceleration? We tried different methods. For example, changing all the materials from metal to carbon fiber, or even getting rid of protections just to decrease its weight by a little. But none of them seemed to give enough speed that we wanted. So we were trapped again. But luckily, one day after training, we met a professional RC team. Instead of using the traditional drivetrain, they used something else, a different model. It was a belt drive. They used, instead of a metal rod, they used a plastic light-weighted belt. That was awesome. We thought, why don't we just use this on our competition car? Wouldn't that just help us increase the acceleration for our car? But how will we actually implement it while staying within the rules? The regulations were strict. Instead of actually redesigning every single component of the car, we thought we had to think outside the box. Why don't we just redesign the chassis? The chassis, we used 3D modeling that paired the original model with the new belt drive model. This gave us enough acceleration for our new car. Eventually, this innovation led us to have a comparative advantage against every single racing team on the field, also while staying within the rules. When we brought this innovation to the United States and the international stage, they were amazed. The competitors and the officials, they've never seen something like this. It was the first time in competition history that they have seen such an advanced innovation. This shows the beauty of engineering, how the ability to apply pre-existing technology in surprising ways to solve real-world problems. As the author Tim Ferriss once said, it isn't enough to think outside the box. Thinking is passive. Get used to acting outside the box. But being a successful racing team, we not only have to consider racing, we have to work like a company, consisting of diverse talents from different fields. Now, let me introduce you to GT Racing. I'll first give you an example of how this collaboration works and why it's so important. Let me use this car shell for instance. The aesthetics of the car shell is designed by the design department. The aerodynamic shape of the car shell is modeled by the engineering department. And finally, the sponsorships are negotiated by the business department. Only when these three departments work together coherently, then can we produce this quality car shell. Not only that, but the most important thing about these three departments is that it can provide varying perspectives for our team to make the most optimal decision. For example, our budget is extremely tight. Even though we have sponsorships, well, we often face a trade-off between cost and efficiency. For example, when we're choosing our material for the car shell and chassis, we wanted to use a more expensive and commonly used carbon fiber material. But our business manager gave us another idea. Why don't we just replace it with a more cost-efficient and cheaper material like plastic that had similar durability? This nuanced perspective allowed us to save a large portion of our budget on modifications, which can be reinvested in R&D projects. Another important role of the business department is making and acquiring sponsorships. We often have to make business presentations where we have to effectively demonstrate our team's values and what we care about. But in order to do so, we need an eye-catching logo. This is when the design department comes in. A good logo has to consist of what we actually care about. For example, the horse icon is a representation for our team's legacy, as horse and chariot racing are usually associated as the predecessors for car racing. And the laurel wreath on the right is a Greek symbol for victory, as that is what we seek for in every single competition. It's these minute details that make us one of the most iconic and remembered team in the competition. Ultimately, only when these disparate yet complementary departments work together, then success is guaranteed. These interdisciplinary innovations and collaborative teamwork allowed us to become the first ever Chinese team to win the international championships. Lastly, what I want you to gain from this speech is that life is like racing. You often face yourself solving a problem alone. For example, doing your own math homework, conducting your own physics research. And you often get stuck on just one single problem that you have no idea how to solve. And every single solution seems like a dead end. But as the writer Dan Brown has said, sometimes a change of perspective is all it takes to see the light. When you feel like you're trapped in a hole, go look at the world around you. Maybe something so minute or irrelevant can inspire you of a new idea. Even more, look at the problem through a new perspective or another discipline, and that might just give you hints to the solution. Lastly, humans are social beings, so eventually in life, we will not only have to conduct independent projects, we will also have to work together in a team, be part of your own community, or even organizing your own company. This is when teamwork is so important. You have to have the ability to understand other people's perspectives, listen to different voices, and engage in collaboration. Use the power of perspectives, and it might just change how you look at the world. Thank you.